Welcome everyone to this session of demystifying the computer vision with a wrong spelling of vision on the slide. Apologies for that. Okay. So let's begin. Just leave it like that.
Okay,
We'll just start.
okay. So now we'll be starting our hands-on session on computer vision. So what is basically computer vision? The first of all thing is now till now we have studied machine learning, supervised learning. So do you remember there was a subset of diagrams we have studied? So there is a broader domain. The broader domain was AI. Inside AI there was ML. Inside ML there was deep learning. ML means represents your machine learning. Then there was deep learning. And inside deep learning, there is a technology called as computer vision. So what is computer vision? So it is a combination of two terms. First is the computer, another is the vision. So this computes digital images. So you have images, you have pixels. Okay. So it's completely working on pixels. Till now you are working on numbers. Okay. So it is a collection of pixels. Computer vision. So it analyzes pixels and generates an inference on that pixels. It gives the output. Okay. So there are two majority terms involved in computer vision. The first is called as image processing and another is called as computer vision. People often quietly mix these two terms and say they are one and the same things. Okay. But there is a major difference in image processing and computer vision. Okay. So what happens is image processing is transformation techniques. Okay. So you have your data set T. So you apply some transformation like you have done some feature scaling. You are standardizing the output. If your output is in the range from 1 to 10,000, then you try to reduce in the scale of 1 to 10. So what is this? You are applying some kind of features. You are reducing the features value. Means you are performing some kind of operation on that data. So what does image processing represent? Image processing represents. So if your image, you are performing some kind of transformation. Transformation means whether it can be reducing the image size, it can be scaling. Okay, so smoothing, sharpening. Okay, so all this comes under image processing. So image processing is just a task of performing different processes on the image. And what does computer vision does is it understands the image. So whatever image you have provided, and it gives some conclusion or insights. So basically we want insight, but you won't be able to generate insight if you aren't doing image processing. Okay. So we have studied till now in supervised learning or any linear regression, logical regression. We were performing some kind of scaling. We are dropping some columns. We have removed some null values or null values. Okay, so we are doing some kind of processes on the data set. Similarly, you can't directly pass your image into the model and say whether it is a cat or a dog. Okay, so it has to do some pre-processing. So for that pre-processing, we use term called as image processing, which does the smoothing, sharpening, contrasting, and other things. And what does computer vision do? After the image is getting processed, it understands the image and draws some particular insights from that. Okay. So now I guess so we have installed the OpenCV library. So we will be using this library in today's lecture. So if you're not installed it, just quickly install it. Quickly install. Just type into the chat box if you have installed the library, OpenCV library. And make sure you are using your local environment like Jupyter or Atom or VS Code, PyCharm to use full app. I won't be recommending. Only in this session. Otherwise, you can. Yes, I want some replies if you have installed the OpenCV library. Okay, done. Okay, great. So if you are import the OpenCV library, you can check the version CV2 dot. So underscore is missing here. So you have to like underscore version underscore. You can check what is the currently version computer vision library installed in your system. Okay. Now we'll be particularly moving. So you have learned listened about what is OpenCV. So we're missing what is OpenCV. So OpenCV is an open source computer vision library. So in the case of machine learning, you have studied. Can anyone tell me which libraries you have studied in machine learning? A library which we are particularly using in machine learning. It was very common in all of the algorithms we have studied. There was one library. Okay. So you can drop into the chat box. Else I can give us. Okay, great. Okay, absolutely, Rutuja. It is called as sklearn. Okay, NumPy, Pandas, yes. They are the great libraries. Okay. So in machine learning, we mostly use scikit-learn, sklearn, Pandas, NumPy. So all these are the libraries. Similarly, in computer vision, there is a library called as OpenCV. Okay, so it is used for image processing and drawing some insights from that image. Okay, so OpenCV is a computer vision library and it is also machine learning software. Okay, so now we will go on to the main part. So the final project we will be doing today is called as what is today's aim? Or today's aim is to detect your faces. Okay, so my drawing is not that good, but okay, so you have to detect your faces. So it will be able to detect your faces. So okay, so basically we will be starting. So in the last lecture, last lecture, I guess Athurva has told you image is a collection of pixels. Okay, and the pixels value ranges from 0 to 255. Okay, for any image there are three primary colors, and you know that. So there are three channels. Okay, for an image. So imagine. So this was your first channel beside there. Let me grab it. So there are three channels, namely red, green, and blue. Okay. So first channel is your red channel. In any image you have heard of, the first image is red. The second layer is consists of green layer, and the third layer consists of your blue layer. Okay. So it is a collection of three layers. Okay. Any color which you are seeing right now is a collection of all these three images. Okay. Some proportion is slightly changing, but the images consist of three layers. So red, green, and blue. Okay. So these three collection of these three layers make your complete image, and your image ranges from 0 to 255. Okay. Means your pixel value ranges from 0 to 255. Okay. And collection. So images. So basically, when you are doing the coding purpose, we will see. So there are three types of arguments which we can pass during loading an image. So when we are loading an image, so this is our image I. So when I am reading with the value argument 0, okay. So when I'm passing the argument 0, it will return me a gray form of that image. Okay. So if your image is colored image, if I'm passing the argument 0, it will return me a grayscale image. If I'm passing the argument 1, it will convert into color scale image. But if I'm passing the argument as -1, it will return the same image. If it is gray, it will be gray. If it is colored image, then it will be colored. Okay. So means if you're passing -1, the image will be getting unchanged. If you're passing 0, then the image will be getting converted to grayscale. And if it is 1, then it will be in color. Okay. So now we go on to the coding part. Okay. So if you have any folder, any file or any image that you wish to do for your CV thing, just load it to the local environments, means you are currently working directory. So I have the image Dodge. Okay, so all of you know, or if you don't know, Dodge is cryptocurrency. So we will be using that meme coin image for doing our computer vision thing. Okay, so just get onto the code. Okay, so if you're open up your terminals, if you're PyCharm, GitHub, PyCharm, Jupyter Notebooks, whatever you have. Okay, so we will be moving on to the coding part right now. Yeah, I am read. First, we'll be reading the images, and don't forget to give the extension as Python. Okay, read.py. I will be. Okay, so when it is ready, and let's start by reading our image. Okay, so first of all is import your CV2 library. Okay, I guess so. I have the CV2 library. CV2 represents for your computer vision library. Computer vision library. Okay, so next the command we will be saying is I'm creating a variable img. Okay, inside that img, I am using a function cv2.imread. So what does this function does? It reads the image. Okay, so this function cv2.imread is using for reading a particular image. Okay, So let's hop on. Okay. To where were we? Uh, okay. So cv2.imread, this command is used for reading an image, and inside that we'll be passing on to the image. Okay. Make sure you have any photo. Let it. If you don't have any photo on your local system, just download it from net. Just see what is the extension of that image and load that image. Okay, so I'll be loading that image. cv2.imread. Inside that, I am reading the image. So my image is present here. Dodge.jpg extension is there. Okay, so dodge.jpg. JPG. Okay. And now we have just now studied that we have three parameters to passing. If I'm passing -1, the image will be getting unchanged. If I'm passing the value as 0, so it will change from colored image to grayscale image. If it is 1, it will be changing. If it is gray, then it will convert it to colored image. If it is already colored, then no issue. Okay, so this is my image of Dodge. Okay, so this is the image we will be performing. So it is a colored image, as you can see it. And now I will be reading into the grayscale. Our command was 0. Okay, and just type along with me. So next thing what we'll be doing is print our image. So in image, what is stored? Currently, image our pixel values are stored, and our pixels value ranges from 0 till 255. Okay. So what it will give us? It will be giving us values from 0 to 255. Means basically it is reading the pixel. Till now we have not read the image. Okay. For reading the image, we have another commands. We just think it. Okay. For reading the commands. So so this is cv2.waitkey. So this is the first command which we will be using. So what this command does is, it is a keyboard bound function, means it will tell the program to wait till any particular time. If I'm not specifying any time, it will wait till infinite. If I'm passing the argument as 0, it will wait till infinity. Okay, or for other value, it will wait for that particular time period. Okay, so in the parenthesis, so you have your parenthesis. In the parenthesis, if you specify the value as 5, the image will be open for 5 milliseconds. As soon as 5 milliseconds are over, your image will be getting closed. Okay, so image will be getting closed. If you're passing the value as 0 in your parentheses, then it will be open for infinite period of time. And if you have to do the manual closing of that window. Okay, if you don't do it, or it will be getting open till infinite time. The next command which will be seeing is cv2.destroys all window. Okay, so once you have opened the window, you have to close all these windows. And for closing the windows, we will be using destroy all windows. Window means basically your image will be read into that particular window. Okay. Just
Basically, when you are doing image processing, a window will be open, right? Showing your face. So you need to close that window. So that was that process. And that wait key is nothing but it tells the program to wait for certain time. Okay.
Yes.
So wait key, and inside that the number you tell, it just says that please wait for that much amount of milliseconds. Okay, and if you press 0, then it's like, okay, you manually close your program by yourself, I won't be interfering. But if you like enter any value, so it says that I'll wait for this time, so you enter any particular key.
Okay, so now just we are inputting our library. So cv2 is using for your computer vision. I created one variable img, then I am using the function cv2.imread. Okay, so basically this function was used for reading your image. So now your image is just read. Okay, so I'm passed on to the image and its extension, and since I'm using the value as 0, it will be getting read into the grayscale image. Okay, so when I'm doing the print img, what it will basically return? It will basically return me the values in 0 to 255 range. So just we will see it. Okay, so we have to print the, we have type the program yet.
Save the program first.
Okay. As soon as we save the program, we can see the values. Okay. So and
Yesterday someone was asking me, right, about how to import images and how to build a classifier for images, right? It was rotten fruit or like fresh fruit, something like that.
Yes, for
So
Apple
this is
I
how
was,
you
yes.
build the images. So after this, what you can do? You can just convert. Yeah, see, it was Nakul. So Nakul, you can see now you have your array, and each one ranges from 0 to 255. You can just read each and every image like this. So there is other way. You'll see, like you, it's homework for you. You can find out yourself. So one way is cv2.imread. You can read a particular single image, and for videos you would be seeing right now. So video would be your live video on which you would be doing face recognition.
Okay. So once you are at the image, so make sure you type the commands with us. Okay. So if you are facing any kind of problems, we'll be there to help you. Okay. So we have just read into the image. Now we'll be using cv2.im show. So have read the image. So now our next task is to see what is the image we have read. Okay. So I will be passing I am don't name data passing a variable image. Okay. So this is what does tv2.im show us the image which we are having in the img variable. Now it is getting displayed. Previously it was getting displayed just as a your pixel values, but now it will be getting displayed. Okay. So I'm setting the window name as image and I'm passing my variable img. Okay. The next thing which we will do is see the window will be getting closed very soon in millisecond fraction of seconds. To hold on the window, we have just seen that we use wait key. Okay, so what does wait key does? It will hold the window for a particular period of time. Okay, so I'm not passing any values. So if I'm passing any value, it will be getting closed in that particular. If I'm passing the value as 5, it will be getting closed in 5 milliseconds. But I don't want it. I want it to wait for a finite period of time. Or I want to say that I want to close the window manually. Okay, so for that purpose, I will won't be passing any argument. And at last, I will be using cv2 dot destroy all windows. Okay, so what does this function does is it will destroy all the windows that were open. Okay, so your first command, what was it doing is to show the image. So in the first case, cv2.imread, it has just read the image. So this function cv2.imshow will be showing us the image. Next, this function will be used to pause the image for a specific period of time. Okay, else you won't be getting to see the image. And the last, that if you have any window open, so it will close that window. That was, I guess, so all are done with the code and I'll be running. Okay, so what we can see is the image is currently read into grayscale. So what was the image? So basically this was your image. It was into colorful mode. So why does this goes into grayscale? So we have specified the value as 0 while reading the image. So what does 0 represents? That your image, whether it will be colorful or any color, it will be getting read into the grayscale. For 0, it represents grayscale. So suppose if I am passing the value as 1, then it will be getting changed into the colored images. Okay. So my new terminal. Python read how that image is getting into the color. Okay, so we can see if I'm giving the value as 0 into the colored blue. Okay, so that's the main logic behind. And in computer vision, most of the processing or most of the video images which you will be reading is you have to read it to the grayscale format. That's why grayscale is very much important. So any doubts still here? You can ask it right now. We will stop for a period of time till you guys process these codes. Okay. And if you have any doubt, just ask
And
it.
does everyone remember why it was ranging from 0 to 255, a value of 1 pixel? I told you that day we were doing our number, like our number regression, right? Sorry, number classifying from 0 to 9.
Amnesia data set.
MNIST data set, right? So I told you one thing, that one pixel uses dash amount of data to store, like the dash amount of size. It could be what? Does anyone remember? Somewhat bits, or maybe byte, or megabyte, gigabyte. What was it? What was the storage space for one pixel? No one remembers?
Okay, Nakul has
8
got it.
bit, exactly. And 8 bit is nothing but 1 byte. So both are correct, right? So 1 byte, and in 1 byte there are 8 bits. So for 8 bit there would be total of 256 combinations, right? So 256 types of combinations of 0 and 1. So that's why you have range from 0 to 255. And the thing is, so it was for grayscale, right? So one pixel was using 1 byte of storage for grayscale images only. Now when we have RGB images, okay, when we have colored images, we basically have three filters, that is red, green and blue. So that time we have 3 bytes per pixel. Okay, we have 3 bytes per pixel. Just remember this thing. For colored images, you have 3 bytes. Okay, one to store red values, one to store green values, one to store blue values. So at the end, what you get a colored image. And for grayscale, you only require 1 byte, because from 0 to 255, what you are going to show? You are going to show just the amount of whiteness, right? It is nothing but the amount of whiteness. So I hope everyone understood. If you have any questions, you can ask right now, or we'll just proceed ahead.
Yes. Also, if you are done with doing this code, if you are facing any issue, just tell us, or we'll moving forward. Okay. So she says it is clear. It says no model named CV2. I tried PowerSheet, it shows my path in the C drive. I guess, Daryl, you haven't installed your computation library in your particular directory. So just make sure you are installed in your particular directory. So now pool 0 to 55 means it the pixel value ranges. So all the pixels are present in the that format. 0 to
See, 0
55.
is black, 255 is white, and in between all the 255 shades of gray. Remember? And hello sir, due to something I was not able to attend the first session. This is the first session I'm attending. Is there any way I can move? Well, yeah, Deepikshika, we have uploaded our videos on our YouTube channel, IEEE CIS SBC JHRC. So you can rewatch those sessions from there.
I
Okay,
guess we
reverse. No, it's not reverse. 0 means black, 255 means white. Bas utna hi.
Vishal can drop the link, and Dipshika. So this session is completely different from your previous session. So this is a complete hands-on session. Okay. So I guess so there is no doubt. So we'll be moving forward. Okay.
Yesterday's okay, Sanskar, I'll check in with my team. Recording was done. Probably uploading would have not been done. So don't worry. Today you will get both the sessions, yesterday's and today's.
Okay. So have you read the image correctly? And if you are read the image, we can move forward. Okay, Nakula says it is done. Okay, so we'll be moving forward. So now what we does is, so we have basically understood how to rate the images. Okay, so now the next thing which we'll be seeing is how to resize the image. So if your image into the format of 130 by 80, suppose this is 138 by 84. Okay, so sometimes you need to reshape this image into say 250 by, wait, my handwriting is so bad. Sometimes you need to do the formatting into 250 by 250. So in that case, you use the function for resizing the image. So image resizing the process of changing the image size. Okay. So your quality of the image, so your properties won't be getting changes, just the size is getting changed. Okay. So again, if you want to rate the image, so you can rate the image in your format and it will be getting resized. So you don't have much worry about this. So we'll be seeing this session soon. So now the main part comes into play, that is face detection. So how does face detection actually works? Okay. So there are three components, okay, basically to come into play. So the detection, as I have already told you, the all the detection, whether it be image or video, you have to perform your colorful image. Colorful image means your RGB. You have to convert your RGB image into grayscale. You can't directly perform your operations on RGB channel. Okay. So the detection works only on the grayscale images. So first, what the first thing which we'll be doing is to convert your image into grayscale format. Okay. Next is your detect multiscale. Okay. So this is the function which we'll be using. So what does the function take? The function takes three arguments. The first one is your image. Okay. So the image which you will be loading. The second one is your scaling factor. Just now we have showed the scaling factor. Scaling factor means resizing. If it has a higher dimension, you want to convert it to the lower dimension, or else vice versa. Okay. So we don't have to much worry about this. The care will be taking itself. And the third is minimum neighbors. So the minimum neighbors you have to do your Kenyan algorithm. So what is that tries to do is it will try to classify more similar points in a one group. Okay. So that's the typical use case of Kenyan algorithm in your computer vision. So it has three inputs. First was your image, second was your scaling factor, and third was your minimum neighbors. Okay. So these three factors we have to pass on as a hyperparameter. So what does the scale factor does is it specifies how much the size reduced with each scale. And the minimum neighbor tells us, okay, so how many pixels do I have to assign? Okay. In 90% of the cases, the value remains the same. Okay. But if you're not getting the correct accuracy, you may just have to tweak the parameters a little bit. Okay. And at last, if once you are detected your face, so you are detected your face. So this is your face. Now we have to plot a bounding box. So how I'll be getting to know that this is your face or this is your hand. So around your face, I'll be drawing a bounding box. And to draw the bounding box, what is a box made up of? Box is just made up of coordinates X, Y, Z, A. Okay, so faces contains the coordinates, and we'll be finally drawing the coordinates using the X and Y axis. Okay, so these were the theoretical concepts. Let's just move on to the practical approach to get the insight. Okay, so we'll be again making a particular notebook, different notebook for this purpose. Okay, so just open another notebook and file as event. So again, the first thing which we'll be doing is importing our library. Okay. Again, importing imports CV2, my library is getting imported. Okay. Now, what does the face classification does is it will try. It is already pre-trained. You don't have to train the network. So what were we doing in the case of machine learning? We were training the whole system, like we were importing from train test plate, import from model selection. We were importing train test plate, then we were training the model, and after that we were predicting. But in the case of face detection, there are pre-trained models. You don't have to train the models from scratch. Okay, so that pre-trained model is called as cascade. Okay, and there are various cascades available. So there is face cascade, there is smile cascade, there is eyes cascade to detect your eyes. So there are various cascade available for CV. You don't have to train them from scratch. Okay. So the current cascade which we'll be using for face detection is called as hair cascade frontal face. Okay. So Atharva, you will be providing the file. Atharva, have you uploaded the file onto the GitHub?
Yeah, I uploaded the file on GitHub. So everyone just go to our GitHub repository, and in week 4, you'll find this file. So just go into raw and save it as .xml extension. Okay. So just for how for CSVs, we were seeing the raw image, right? For CSVs, we were clicking on that view raw button. So just click on that view raw button on GitHub and then save the file as .xml extension. So that's how you'll get the file. Or simply, if you don't want to, like you don't know what's going on, don't worry, just go to our GitHub repository and download the zip and use that hair cascade frontal face file. And like keep that file wherever you are creating this notebook of yours. Okay, so they should be in the same directory.
Okay, so this is in my same directory, my R cascade, frontal face, and my event.device. They are in the same directory. So make sure if you are not putting into the same directory, then it will be throwing the error. Okay. So first of all, we have imported the library CV2, just like we use import pandas as PD. So that's why that's the same extension we use CV2. Okay, for short abbreviation. Now I have defined a variable name as face cascade, and inside that face cascade, I will be reading the file R cascade frontal face. Okay. So I will be reading it using CV2 dot cascade classifier. Okay, so that's the reason why you VS Code that you just get the suggestion and you don't have to type the whole code. Okay, so you have to just type CV2 dot cascade classifier, and inside that cascade classifier, I will be passing on to the name of my classifier. Okay, so the name of my classifier is at cascade.
It's nothing but the file name of that XML.
Okay, I'm just reading the file name. Okay, so this is my file name. I'm just reading the file name.
And you know, like what that actually file is. So research scientists, okay, some data scientists, what they did was there were like thousands and millions of images. And in that, they created a machine learning model in which it can detect faces. Okay, so there is a machine learning model who knows how to detect face on millions and millions of images. So right now, we don't have that millions images, right? So the beauty of machine learning is that we can utilize the things learned from their machine. Okay. So the research scientist must be having a huge supercomputer in which they taught that machine how to detect faces. Okay. And they can export that knowledge, the knowledge of how to see and look for faces. So they can just export that knowledge into these files. So har cascade file is used in OpenCV. Similarly, saved files can be exported in like pickle extensions, or there are other extensions. Okay. So that's the beauty, because any model you train, you can export it so that others can use it as well.
So if you will be studying deep learning, there are lots of pre-trained models. So you don't have to train your models from scratch. Okay. So because they require huge amount of data. Okay. So you are getting that model basically for free. You just have to load that model. Similarly, the cascade model you have available, it is already pre-trained. You don't have to train on millions of images. So okay, I had done reading the cascades. For reading, I using the function cv2.cascade classifier. Okay, what this function does is it will be reading the file which we have just loaded. Okay, so I am reading the file R cascade. Next thing we have to do is, since we have to capture our face, we will be reading our video files from the webcam. And to record these files, I am defining another variable called as cap. And inside that cap, I am using cv2.video capture. Okay, and inside that video capture, I'm passing the value as 0. What does 0 signifies here is 0 means you are recording you are getting a live stream from your webcam. And if you want to get a particular, if you don't have webcam, you can pass on to the particular file name. Okay, so file name dot mp4. Okay, so if you have file name, you can pass on to this. But since I'm using my webcam for reading my images live or reading my face live, I'll pass on to the value as 0. Okay. And what does this does is capture video from webcam. Okay, we have read the image, your video from your webcam. The next thing which you have to do is, so what does a video is? Video is a collection of series or frames. So what is a frame? Frame is just an image, and collection of images forms your video. Okay, so since there are infinite number of frames which will be reading from our webcam, we will creating an infinite loop. An infinite loop for creating infinite loop when we don't know how many iterations we have to proceed. In that case, we use while loop. If you know that for 100 iterations I have to run my loop, for that case you use do while loop or for loop, generally for loop. But if you don't know till what iterations you have to run, in that case you use while loop. Okay, and I'm specifying my condition is equal to true. What does true represents? True represents means it will go on into infinite loop until I break it. Okay, so while true, I am running my infinite loop. The next thing which I will be doing is reading my frame. So what is video made up of? Video is made up of frame, and now I will be reading the frame. And for reading the frame, I'm passing underscore and img. So what does this do? Okay, so just let me write it. Cap dot read. Okay, so I have made the while loop for processing infinite number of frames. Next thing I'm doing is I'm reading underscore and image. So what does underscore represents? Underscore represents here is the frame which we have recorded from your webcam right now is being read correctly or not. If it's being read correctly, it will be going on to the image variable, and the image is getting stored into the form cap.read. Okay, means you are reading. Okay, so just type into the code along with me so you don't have doubt.
Basically, this cap.read, it returns two variables. Okay, it returns two values. The first value will be a boolean whether you are able to read from your video camera. Okay, so you have a video camera from cap, and what is that cap? cv2.video capture, right? So from that cv2.video capture, am I getting any visual input or not? Yes or no? So that is the first variable that Aditya used underscore for. And if I am getting any variable, like if I am getting the image, then I'll use that image. So that's why that img will store that image. So any video input that I'm getting from the video camera. And that video capture, the zero is nothing but like for people who have multiple cameras. So it could be zero, it could be one or two, something like that. Zero is nothing but your camera number. So default is zero. But if your system has two to three cameras, then you have to change it to one or two and try which camera is for your system. Okay, so let's proceed.
Okay, so once you are at the frame, the next step is you have seen that you have to convert it into the grayscale. Since in the image, the frames can be read into the RGB format. So next thing, what I'll be doing is I'm defining a variable called as gray, and inside that gray, I'm using cv2 dot convert color. Okay, so what does this function do is if my image is into RGB format, it will be converting into gray format, or else vice versa. Okay. So it will be converting into gray to RGB, or else RGB to grayscale. But in this case, we want to do our RGB image into grayscale. That's why we will be passing on to the first argument which it will be taking is your image, which I have read img. Next thing is cv2 dot color bgr. So what does bgr represents here? So we have been talking of RGB. RGB represents your red, green, and blue. But in ancient times, it was being read as BGR, means your blue. The blue was in first, blue, then green, and then at last yours red. Okay. So by old convention, we write BGR. What does two represents? Two means you have to convert, and gray. Gray means from BGR format, blue, green, red, you have to convert it to the gray format. Okay. Now we have got our image into the gray format. The next thing we will do is to detect the faces. Detect the faces. Okay. For detecting the faces, what we will be doing is we will be again defining a variable called as faces. In faces, I will be using that R cascade filter which I already loaded. Okay. So I'm just using that face cascade dot, and now we have seen that a function called as detect multiscale. Hold on. So detect multiscale. So it is the most important function in your while using your face detection. So it will be taking three arguments. First was your image, input image. The second was your scaling factor, who means how much times I have to reduce or enlarge my image. Third is minimum neighbors I have to consider while showing my photo. Okay, so I'm using face cascade dot detect multiscale. So it will be taken onto the three arguments. First one, the image we have converted into the gray format. The next was a scaling factor. So my scaling factor, generally we keep it as, so for my image, it was working perfectly for 1.1. So you can tune the parameters and say, so by default, you can use my parameters. If it is not working for you, you can change these parameters. It's up to you. The next thing I'm using is k is equals to 4, means it will be selecting k nearest 4 points to classify my object is face or not. Okay. So once we have detected the faces, so we have to plot out the area around our face. For plotting the area, we will be using a rectangle. And what is a rectangle made up of? It is made up of coordinates. So we'll be drawing the rectangle. So again, I'm using a for loop, and for loop inside for loop, I'm passing x, y, w, and h. So these are my coordinates in faces. I directed my face. I'll be using this to read for plotting the bounding box around my face. So I'm using CV2.rectangle. So that function is used for plotting a rectangle around your face. The first argument which we'll be taking is your obviously image. The next thing is your x and y coordinate. Okay. And the next coordinate which we will be using is your x-axis plus y-axis. So x-axis is represented by your x plus your width w, and your y-axis is represented as y plus height. So this represents your y-axis. Next thing which you will be doing is, so the moment when you are plotting your rectangle, so you have three choices: red, green, blue. So what color rectangle you want? मतलब तुम्हारी frame कौन सी color की होनी चाहिए? So what should be the color of the frame while plotting the rectangle? Either it should be red or green or blue. So it's up to us. So the typical format we just follow is BGR format. So suppose I want my frame to be in the blue color. I will say that it is 255, 0, 0. And how should be the width? How should be the thickness of the frame? So I'm saying that thickness of my frame should be 2. Okay. So till now, any doubts? So it's a little bit of out of machine learning, but yeah, it's wonderful once you see the project. Anyone facing any issue?
Looks no doubts. I think we're good to go. Just show them the output, then I think they would be interested.
Okay, so next thing I have read my image. Yeah, I have drawn the rectangle of the box. The next thing I will be doing is my display my image. Okay. Sir, what was 2 again for? Okay, so 2 was for your thickness of your frame. So just let me go on to the slide. So what does 2 represents here? You have a rectangle. Consider this is your rectangle. How should be the thickness of the rectangle? So this is your thickness. If I want it to be more thick, so in that case, I will be specifying my 2 value as much higher. Suppose my thickness in this highlighter is much more. So I can see that. Okay, so now you can see that my thickness is getting increased. So it is just basically used for thickness. Okay, so if I specify the value of 2 as 1, it will be like this. But now when I'm specifying the value as 4, or if I'm specifying the value as much as, then the thickness will be getting increased. Thickness means the boundary values. Okay, so it will be getting much thicker and thicker. Okay, so that's the thickness used for. Okay, so now it's time to display our video. So CV2.imshow, which I already seen the function. Again, I'm saying that it should read img, and I'm passing my image variable inside that. Okay, so once you are read the image, so it will be come for a millisecond and it will wipe out. So for holding that screen, you have to put some condition. I have to stop if my escape key is pressed. So my program will be getting terminated if I'm pressing the escape key. Escape key is pressed. So now I'm defining a variable k is equals to CV2 dot wait key. We have seen that wait key will hold on for a particular period of time. So I can say wait for 30 milliseconds, or else I can say into the ASCII format of 0xf. What does this particular key do? It will wait until I press the escape key. Till that time, it will hold the image. Okay. Next time, if k is equals to 27, k is equals to 27 represents your escape. Okay. So what A to Z, A to Z represents your alphabets from ranging from 1 to 26, and K is equal to 27 means your escape key. I am breaking this using a break. Okay. So once I have read the first thing we have done is I have imported the library. I have laid the cascade, means my pre-trained models. The next thing which we are doing is we are reading the continuous frames from our webcam. Okay. So it's collection, since it's a collection of webcam, we don't know how much time till मतलब कितनी देर तक मेरे को webcam on रखना है. Okay. So I will giving the infinite loop. Inside that infinite loop, I'm passing the two variables underscore and image. Underscore represents whether my frame is read correctly or not. The next thing it is doing, if it is read correctly, it will be storing into the image variable. The next thing I'll be doing is I'll be converting into the grayscale format. Okay. For grayscale, I'm using the function cv2.cvt color. Means it will be converting my blue, green, red image into grayscale. So once it is converted, now I'm good to go with detecting the faces. For detecting the faces, I'm using detect multiscale. First argument is your grayscale image, the frame which you are loaded into the gray format. This is your scaling factor, means how much you want to scale, how much you want to enlarge or reduce. The next is your 4. 4 means your nearest neighbors you want to select. So the threshold I am selecting is it as 4. If I'm reducing the threshold, it will be considering the objects which are not face, as it will be मतलब जो face नहीं है, it will be also considering them as face. So it is better to set a higher threshold. Once I have detected the faces, I am drawing a rectangle. So how come I know that this is face? So for detecting that, I am drawing a rectangle around my face. For displaying, I'm using silver I am show. And for holding that particular screen, I'm passing a condition. If my escape key is pressed, then it will exit my window. Okay. Last, I will close my window. This my window. Okay. So for releasing, I'm using cap.release. Till now, any doubt you can ask. Athwa, can you see any doubts?
No, no one has any doubts.
So it is that if you don't get anything, then you are not asking doubt, or if you are getting all and each in everything, then that shows you are getting each and everything. Okay.
Aditya,
So
you can destroy the windows, no?
yes, I'm destroying the windows at last. Okay. So I will just run my audio. Okay, so what is done is it is recognizing my face correctly. If I'm pressing the escape key, it is getting closed. Okay, so that's how the function works. Okay, I'll be running it once again. Okay,
So if you guys wrote the commands along with himself, just write yourself as well. See, you'll get your face recognized.
okay, if I'm showing the hand, it is not getting recognized. But if I'm showing my face, it is getting recognized correctly. Yes, that's it. So just run your code. If you have any doubts, just ask it. So are there any doubts?
And if you guys want to, like, anytime if you want to check that what is going on in background of these functions we are using. So for example, we are using this detect multiscale, but what is going on in behind, like in background of it, right? So for those things, what you can do is just Google out these all things in Python. Like Python is everything but open source, right? So in Python, each and every function and its definition and what's happening inside it, you can see it. Just Google it. So for example, there is a big documentation. So I have for like I have for this cascade classifier. Okay. So if this link is working, just check. There you will see that detect multi-scale that we used. And inside that you can see what parameters are available and etc.
So someone was asking about what is the value of 2. Okay, so who was that? The value is 2, I guess. So,
Yeah, the thickness, just change it to
okay,
like,
so I will just change the value of 2 so you can see how the thickness is getting changed. If I'm setting the value of 2 as 10, so now just check how the thickness is getting increased.
see, more thicker rectangles.
So you can see the thickness is getting increased. Okay, so that's why I have reduced it to 2. And you can change the color since I have told you the 255 represents your BGR. BGR formats mean blue, green, red. Suppose I am pass. I want my image to be of red, the bounding box to be red. Then I will specifying it as 00255.
So
In that
what you do is
case,
you can just play with these parameters yourself and see how things happen and what changes happens. Right.
so, okay, so he is learning very much. So you can do with many other filters. So there are many filters for recognizing your eyes, so my mouth, your smile, so hand gestures. So in future, I will be, so if you are interested in future, we will be doing much more sessions on computer vision. So in which way you can detect your bottle, your mouse, your keyboard, your phone, each and everything can be get detected. So there are various computer vision algorithms. So that's why it is a much more interesting field. And I prefer computer vision over machine learning and deep learning. So have anyone tried how to name the rectangle? Nakul, can you specify naming the rectangles?
Do you want to give label to the rectangle, for your data set, something like that, or you just want to like you just want to show your name in that rectangle? Because I think it has a label parameter and there you can give. For dataset would be completely different for, but just to show in the particular frame, there is
Okay,
a
so
label.
this is my okay. So my name is just now shown here, Aditya Bhopre.
And yeah, this is the name of the window.
Okay, so you can change the name of the window. Okay, so Nakul, you just have to change this function, the first parameters, Aditya Bhopre. Means you can put XYZ. Okay, so if I'm putting XYZ and I'm running it, the window name will be XYZ. Okay, so you can see that it is representing XYZ image. Okay, so has Daryl tried it?
Nakul, for that you have cv2.putText. Okay. Yeah. So for that you have cv2.putText and there you can feed the image and the text you want. It will just overlay your name there.
So has anyone tried it? Nakul, are you trying it? I guess so he's only interested.
That's
So
the
he's
code.
paying daily attention. Can I say okay, okay. Sure, Darren. Oh, this is my
Uh,
first. This is my
Aditya,
daily
you can
practice.
just upload the file there, na? Event.py
Okay, yeah, sure.
on GitHub. Just rename it and then upload it on GitHub.
Sure.
Yeah. And so guys, I hope it was pretty clear what happened here. I have keen interest in computer vision and using it with IoT. Okay, that's excellent, Nakul. If you have interest, you should go for it. You know, you can now create various things from it. Now, just you saw how you can interpret with images, right? So what you can do is now, so we had an image like Aditya used key escape to close the windows, right? Similarly, what you can do is give one more if statement there. And with one more if statement, what you can do is you can save an image if you want. So you can create a camera using Python. This is homework for you guys. Just try it out. How to create a camera? Very easy. What you have to do, you can just give one more if statement. So Aditya used the if statement that if anybody presses the escape key, just close the program, right? So what you can do is you can give one more if statement. So if anyone presses any other key, okay, you can give any other key you can just say it to save the image. So you can just create a camera using Python, and that would be for saving. So if Nakul wants to do, let's say, like this was face detection, right? So if you want to do face recognition, so if you want to create a face recognition, what you can do is you have to have a data set. So for face recognition, for particularly you, what you can do, you have this file. With this, you know how to interpret images, you saw in that dog, right? You interpret the image, then what you can do is you can save live videos. So just now, as you can like as I told you, for camera, you can save your image. Okay, once you save your image, convert it into array and just rename it, like you give a y, okay, the label for it, and you can just use the array of 0 to 225 values of the pixels. You can convert it into your own data set, and
Okay.
you can then apply any algorithm, and you can just create your like any classification you want to do.
So not only can you can detect the faces, but there are many classifiers available on the OpenCV file. Okay, so I'll be dropping the link. You can check with the you can check the eye format. You can check. You can detect the full body. You can even check if the person is smiling or not. Okay, so this is the GitHub repo. You can download any one of the hard cascade files. So for this purpose, we were using the face detection. So you can use your eyes detection, smile detection. So you can play with that and show you to your family. So I can detect your face. You are getting watched. So you can play a prank with them. So do you guys like it? Face detection overall from till now. I'm having issue with my code. Okay, can Darren you can specify it? Again, and I have uploaded the file on the GitHub ML Bootcamp. You can check if you have any typo mistakes. I have uploaded into the week 4.
And here open source again, so you have har cascade files. So we used frontal face to detect front face, but not only that, what you can do, you can detect faces, you can detect eyes, you can detect hand, and whatever you want to. Okay, so the repository I provided you, it has such like it has such har cascade files.xml. So you can see there is at top, you can see har cascade i.xml. So you can use that one to detect eyes in a particular frame. Okay, we did face, just try replacing it with eyes and see how you can use it. So you can create a eye recognition, or similarly you can do hand recognition, index finger recognition, and lots of stuff is there. Even there is full body.
Okay, so they are helping each other. Great.
Acha, object has not been removed. Okay, didn't see that one. Okay, so cool. Looks like Nakul's code is executed successfully, right?
Yes. So I'm expecting 3 to 4 or people who have successfully executed the code. Dai
Okay.
was there, she was there.
In fact, if you are not able to code na, just pick it from here. Don't worry, you can try it out by yourself again. And if you don't have, Aditya has uploaded it. So just use this Aditya's code. You can copy paste or you can download and try running it. Python space face.py. See yourself in your own camera with a bounding box. Yeah.
Yes.
I
I
the
Is this your
code.
first project? I'm having curiosity. I copied the code same here. Okay.
Actually, Nakul told, right? It's multi-scale with in camel case. So detect D is small, multi M capital, and scale S capital. I don't think you'll get the same error if you use like capital S for scale. You have to look in for the capitals and camel cases is
Yes, like it is
it's
case sensitive.
case sensitive. Python is case sensitive.
Just if you're having problem, just check into the code I have put into the GitHub. Okay, page.py into the week 4. Okay, Daniel.
I gave you the link here, so just pick it from there. And if anyone has any doubts, now is the time to ask.
I'm also having a doubt. Okay, so is this your first project as a first year student or second year student? So, or else have you done the project previously, any kind of projects?
Any machine learning projects you have done before this, or like except the ones which we are doing live, let's say our MNIST dataset or any other digit recognition or any other using machine learning? Okay.
Much is needed is for okay.
Then face recognition using code from Google. Acha. Okay. Now you don't need code from Google. Now you can do it yourself, right?
Yes, you can show this project on your GitHub as just a small project. Even if you are in first year, you can show this project on your GitHub profile, and you can post it on LinkedIn also. So you can post it on LinkedIn and show your friends I'm doing this kind of project. So you can do multiple projects simultaneously. You can show that I'm doing the face recognition, smile detection, eyes detection. Just post onto the LinkedIn, and yes, you should be majorly actively on LinkedIn rather than your Instagram and Twitter stuff, because your most of the recruitment at the end of the final year will be happening on LinkedIn. So post your educational stuff. If you are attending any event, just post it on LinkedIn. I'm attending this stuffs. If you have done any kind of basic project, upload it on LinkedIn. If you have any GitHub repository, upload it on LinkedIn and show this is my lecture. I'm attending this lecture. I have done this project under these mentors. Okay. Only done the basic